made our division statements, and the next thing I was going to get you to do was to plug in 1 into g of x and see what you get. If you've done it already, you got 0. If you plug in 3 into f of x, a little bit harder, you got 27 times 3, some big numbers, but if you simplified it, you get 4. And if you plugged in negative 2, again, some bigger numbers, but if you simplify it, you get 0. So the first thing we want to do is recognize what do those 3 numbers have to do with the synthetic division and our division statements. What do they have in common? Where do those numbers show up in our synthetic division? And I hope you recognize or see that they are the remainders. So we're going to find out, why does this work? Because this is the first thing we're going to find out. This is called the remainder theorem. If you're dividing by x minus 1, you're allowed to plug in 1, and whatever answer you get is your remainder. Sometimes it's faster to plug it in than it is to do the synthetic division. Other times, the synthetic division might actually be faster than plugging it in. That's okay. But if you plug in the number opposite of what you're dividing by, in other words, notice that the number that you're plugging in would make this equal to 0, right? 3, if I plug in 3 here, it makes this equal to 0. And it's so easy to see why it's the remainder if we look at our division statement. Let's look at the green one. If I plug in 3, I'm going to do some quick mental math. 3 minus 3 is 0. When I plug in 3 into here, I don't care. Times 0 is 0, right? 0 times I don't care is still going to be 0. And then what are we left with here? Plus 4. What's it going to equal? It's going to equal the 4. Guaranteed, because when you multiply 0 times anything, you're going to get 0, and you're going to get your remainder. Notice that works for this one. When I plug in minus 2, this whole thing's 0. And since the remainder is already 0, works out nicely. This is called the remainder theorem. It's at the bottom of the next page. Let's scroll to it. It's written this way. It says, when a polynomial p of x is divided by x minus a, you plug in the opposite of whatever's there. So if it's minus a, you plug in plus a. And whatever you get will be your remainder. And so it's a shortcut or a different way of finding the remainder. We now have 3 ways to find the remainder. You can use long division. You can use synthetic division, which those 2 ways are basically the same, with synthetic being faster. Or you can use the remainder theorem. Videos only show what's on the screen. Whew. So when we look at example 1 right now, it says determine the remainder when it's divided by x minus 3. So what I'm going to do is I'm going to do this with the remainder theorem, and I'm going to do it with synthetic division, and we're going to decide which one we like better. Sometimes the remainder theorem is better, sometimes synthetic division is better, and we'll talk a little bit about that. Since we just learned the remainder theorem, first of all, I'm going to put brackets around this and go, let p of x equals. So if I want to use the remainder theorem, I'd have to plug in 3. That means wherever there was an x, I replace it with 3. And we're going to have to do some mental math. Exponents first. 3 to the exponent 4 is 81. 81 times 2 is 162. 3 to the exponent 3 is 27. 27 times 5 will be minus 135. 3 squared is 9 times 5 minus 45. Plus 15 plus 3. And now we have a little bit of mental math for subtracting. Okay? Most people, when they would have to do this, most people would start with 162, then subtract 135, take a couple moments, get an answer, then subtract 45, take moments, get an answer, then add 15, then add 3. Okay? Adding and subtracting, you don't have to do that way. Personally, for this one, if I was doing mental math, I would probably put all the positive ones together. That's not too hard. It's just 162 plus 118. I hope you can see that that's 118. I would put the negative ones together. Negative 135, negative 45. I hope you can see that that's negative 180. Then the mental math is a little bit easier, right? Sometimes doing things in order makes your mental math harder. Take a moment to look at it and see if there's any ways that you can make your mental math easier. So we get 0. Beautiful. Using synthetic division. All right. Or we could have also done this with synthetic division. How do we do something with synthetic division? Well, we would put the opposite number out in front. Then we would write our coefficients, making sure that they're in the right order, which they are, making sure that there's none missing, which there is not, so no zeros need to be added. Then synthetic division says, bring the first number down, to multiply, get 6, and add 1. Multiply, get 3, add negative 2. Multiply, get negative 6, add negative 1. Multiply, get negative 3, add, get 0. There's our remainder. If I were to analyze which of these I like better in this situation, okay? If I would do a comparison of difficulty in multiplication, I hope you see in the remainder theorem, you had to do 3 to the 4, which is 81 times 2, that's 162. You also had to do 5 times 27. Those are some bigger multiplication. If we look at synthetic division, I think the most complicated multiplication we had was 3 times 2. Okay? That's 6. Good job. If we look at adding and subtracting, we had to put all of these numbers together. I mean, we used some mental math strategies to combine things to make it easier, but still had to do 162 plus 15 plus 3 and get 180. Okay? In the synthetic division, looks like our most complicated adding might have been, 5 plus a negative 6. That gets a negative answer. Right? Generally, the synthetic division will be easier mental math. The other thing that's nice about the synthetic division is once you've written the synthetic division, not only do you get the remainder, but you can write the division statement right away. The remainder theorem just gives you the remainder. Doesn't help you out with the division statement later on. And later on, we're going to want to factor. We've already started factoring if we use synthetic division. I would say that for the most part, I only use the remainder theorem if the number that you plug in is something really easy mental math, like 1 or negative 1. Other times, it probably makes more sense to use synthetic division. But there will be some questions, you'll see them in our homework, that I'll show you that it is better to use the remainder theorem. But most of the time, synthetic division is nicer. So if I went to part B, and it asked me to find the remainder, and we're dividing by x plus 2, that means I could do p of minus 2, ... I'm like, oh, that's bigger than 1. Or I could use my synthetic division. And if I'm dividing by x plus 2, there'd be a minus 2 out in front. 2, negative 5, 5, 3. And that's not to say that sometimes in synthetic division, like, oh my goodness, there's an 11. My multiplication is getting a little bit higher. And then this one's going to give me 22. That is like -54. There's my remainder of -51. Did I make a mistake somewhere?
You multiplied -2 and 2 and left both the 2 down to 4.
What did I do? Oh, I just, oh! Oh, that's so painful. I should just bring down the 2. I mean, yeah, that's just a 2. And now I got ahead of myself. This minus 4. -9. Oh, I get big numbers already, like 13. -26. This will be -19. No. Close. -21. And -42. Now there's my remainder. -30. +42. Oh my goodness. So I think this, you know what? I'd like to say I did this on purpose, but I did not. 45. Third time's a charm. What I want to point out is if you do try to rush, even a little bit, your chances of making a mental math error are quite good. Also, if you don't pay attention in the moment and start thinking about what you're going to do next, because that's my first mistake. I was like, I'm going to bring down the 2 and then multiply it. I'll get -4. I was already getting this number, but I wrote it because I was going too fast. So take your time. You'll make less mistakes. Unless, I mean, sometimes if you like math, if you make a mistake, you get to redo it. And then you get to do more math. So it can be a positive that way. But generally, I'm going to say that most students don't like making lots of mistakes. So take your time, pay attention while you're doing it, and you will make less mistakes. Questions for this one are 4A, 6A,